Okay, this is the practical for mechanics. You have your rotor stand set up as shown. This is the rotor stand. This is your meter rule. This is the spiral spring with pointer. So the length of this spiral spring is 5 cm, which will be recorded on your table of value. So you can see 5 cm. For 10 oscillations, the number of times we are going to oscillate will be 10. Then this is the stop clock for taking time. For recording time, the stop clock, these are the masses. This is 50-gram mass, 20-gram, 10-gram. So the first one we are going to do, you take note of the pointer reading when there was no mass. We are using this side to read. So that's 58, this side. Then you put the first mass. Remember the length of the spiral spring is 5 cm and it's pointing at 58 when there was no mass slotted. Then the first mass we are going to slot in will be the mass of 50. When you slot it in, there will be an extension. You take note of the new length, and that value is at reading 68, as you can see. So you record it in your book. You have mass x1, that is when there is no reading. When you put the mass of 50, when there was no mass x1, record the pointer value. When there is mass x2, 58, mass of 50 grams. The extension is 10, but I recorded in 3 decimal places, so 10.000. All my readings are in 3 decimal places. So I will now take oscillation for 10 oscillations. Depending on what the examiner will ask us to evaluate it. If it is 20, you oscillate 20 times. If it is 30, if it is 15, if it is 5, but now we are just using 10 for the test. So 10 oscillations, a mass of 50 grams, and we have slotted a mass of 50 grams. So we gently oscillate. As you oscillate simultaneously, you on your stop clock. As you oscillate, you on your stop clock. You watch out for 0 errors on the stop clock and you correct it. So remember, we are going to repeat our readings two times. T1, T2. Accordingly, we are repeating our readings. The readings will be repeated for timing so that we can have an average time, and that will give us near perfect result. So we oscillate for 10 oscillations. You pull it down. When it goes up and comes down, you start counting as one. So we do that gently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You stop your stop clock and you take your reading. The reading here is 6. You record in your book 6. Then you repeat, you reset it, you set the stop clock, and you repeat for the second time. 10 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you stop, and the reading is 7. So you record in your book as well. When I did mine, it was 7 and 8. Then you take the average time, 7.5, that is 7 plus 8, 15, divided by 2. That gives you the average. Then since we are doing for 10 oscillations, you divide that value by 10 to find your period, and that will be 0.5. If it is 20 oscillation, you divide by 20. Then t square, you use your calculator and square that value you have here, and that gives you what you have. So you repeat the same procedure for 70, repeat the same for 90, for 80, for 110 rather, then for 130. Then the examiner can expect you to plot a graph of t squared on the vertical axis against extension on the horizontal axis. It should be a straight line graph. As you can see, it should be a straight line graph because the values is increasing, the extension is increasing. Then when we take the values of the period, we also watch out for the trend. Then you should be able to calculate your slope, and with that, there is no how you will not get your full anticipated grade. So watch out for the other clips on for electricity and for optics. Thank you, and I wish you a good outing.